but we're going to cover more material. All right, so this is just talking about free versus bound variables, right? Here's some code, and you'll see X is kind of inputted by the user, and then these guys here are local variables, right? And the scary thing is I got a Y here and a Y here, but they're different scoping, right? This Y might be local variable, right? And what's the scope of these, right? You can talk about the scope of a variable. And right, and this Y down here is scoping up to this guy, not up to this guy. Right? So here, right, here's a similar statement, right? In fact, quite frankly, it's the same statement, right? We're saying, what are we saying? We're saying X and Y are kind of free. They're given to us by the outside world. And then we have a loop over I and a loop over Y, right? And what's their scope? Scope of these guys is just within the bracket, right? And knowing how to parse things without brackets, you know, and those questions I got from that book, and I retranslated them. One of the ways I retranslated is I added a lot of brackets because they didn't have enough brackets, and I was muddled as to what it meant, right? So that's the scoping, right? And they don't have a specific value, right? They're within a loop. While the free variable, right? The green ones are free variables. And so the sentence is kind of, it's true or false depending on which free values you plug in, right? So it's kind of about the statement about the free variables, right? People following this? Right. And if so there's a difference in the world between a formula and a sentence. There's a difference in the world between valid and a tautology, but we're not going to get into the nuances, right? A tautology is, if you're just doing and or not, you get tautology. And if you're doing for all and exists, it's valid. And why the difference, I don't care, right? And here, the difference between a formula and a sentence is whether it has free variables, right? All right. And so one thing that's kind of useful to say is in a meta world, right? We're stepping outside of the logic. Outside of the logic, I can say, hey, let's define this sentence to be alpha, right? And note that it has true free variables. It's kind of like you give me an object for X and Y, and then I'll tell you whether or not it's true, right? Everybody see that? So what is alpha? It's a function that takes on two objects and returns true, false, right? Everybody get that? Right, and so I write it because I want to emphasize who the free variables are, right? And then, right, you can plug in what's alpha of 5, 6. Well, you plug in 5 and 6, and you get this statement, right? And this statement is, once you've defined your model, right? Once you define A and R, this statement is either true or false, right? Here's another common notation, right? It says alpha is some, I forget, is it a formula or a sentence, but it has a free variable X. And you're supposed to replace the free variable X with the 5. Right? All right. So now you can say, well, who chooses X and Y? Right? Well, they could be specified by some user, right? Some user says, hey, I want to know it for 5 and 6. Or we could build other formulas, right? Here we have a formula we're saying for every X, there exists a Y, right? We quantify them, right? And now we know who the adversary comes up with the X, and then it tells you the game that we're going to play, right? Does that make sense? Another way is if you just are told to prove this, right? Then you're assuming that you're proving it's true for all values of the free variable, right? So there's an implicit for all X, for all Y in front. And so who's kind of doing it? Well, it's the model, the universe, the interpretation that's defining the values of the X and Y. Right? Does that make sense? This guy nods. Everybody else is dead. So I'll just look at him. And if he understands and you don't, it's your problem. All right, everybody good? Right? And so if our goal is to prove that a sentence is true in every model, every universe, then it's true for every value of X and Y that the model plugs in. And so it's kind of that the adversary gets to choose the model, right? If we want to prove for all models. And so there's an implied for all in front. Right? Everybody good with that?